Welcome viewers. In today's mathematics class, we want to take the binomial theorems and the expansion. Okay? I want you to watch this video to the end. Meanwhile, subscribe to my channel. Let us dive in. What is binomial expansion? I will start by giving you this expression a plus b all to the power of n. The definition of a binomial theorem says summation of k starting from 0 to n of n factorial all over n minus k factorial, then k factorial. Alright, next is a raised to power n, then b, that is n minus k, then b raised to power k. This is the formula for binomial expansion. Alright, we are going to use this to expand this expression a plus b raised to power n. Therefore, this summation implies addition of all. As you expand, you add. Whereas this part of the expression takes care of the letters and of course the powers. It takes care of the powers of a and b. While this side takes care of the coefficients. Okay, now let us try to do the application part of it. I have a plus b raised to power 2. I want to expand it. Going by this formula, what it means is that n, letter n, is now equal to 2. So I will have it 2 factorial all over. Remember, it starts from, k starts from 0. So what I will have next is 2, which is n. 2 minus 0, which is going to give me 2 factorial. Okay, n minus k. Then also 0 factorial. But before I continue, let us quickly put this down. K ranges from 0, 1, 2 in this case. Also, I want you to note that 0 factorial is equal to 1. 1 factorial is equal to 1. 2 factorial means 2 multiplied by 1, which is equal to 2. 3 factorial implies 3 multiplied by 2 multiplied by 1, which is equal to 6. Alright, 4 factorial is the same thing as 4 multiplied by 3 multiplied by 2 multiplied by 1, which is equal to 24. It continues in this order. Just take a look at it. I just want to talk about this factorial because we shall be using it, as you can see, in expanding a plus b raised to power 2. Ordinarily, you know that a plus b to the power of 2 is the same thing as a squared, then a times b, then times 2, which is plus 2ab, and then also b squared plus b squared. You square the first term, multiply the 2 times and multiply by 2 to get the middle term, and then you square the third term. That is what we are meant to get. But we want to follow the formula for binomial theory on how to do expansion. So we are starting from power 2. Alright, we move on. Okay, like I said, that this part takes care of the coefficient. So I now take care of the power side. Therefore, I have a raised to power n minus 0, which is 2 minus 0 is 2, and b raised to power 0, plus the next I have is 2 factorial all over. This time around, k is 1. And when k is 1, what I will simply have is 2 minus 1, which is 1 factorial, leaving me with a to the power of 1. That is n minus 1. That is 2 minus 1 will give me 1. And b this time around is 1 because the value of k is 1 at this time around. So to the power of 1. Next, remember I will stop at when k is equal to 2 because that is the highest power in a plus b that I am expanding. Alright. Therefore, next I have is 2 factorial all over. This time around when k is equal to 2. So the value of n is 2 minus 2. Okay? And 2 minus 2 will give me 0 factorial, then 2 factorial. I now have again a to the power of 0. What does it mean? That n, which is 2, minus k, which is also 2, 2 minus 2, will give me 0. And then b is equal to k, b is to the power of k, and k this time around is 2. I hope it is making sense. Therefore, if we try now to work on this, you will agree with me that 0 factorial is 1. Therefore, 2 factorial will cancel 2 factorial to give me the coefficient as 1. Remember, this whole of this takes care of the coefficient. So what I have here is a to the power of 2. And you can see that b raised to the power 0 is 1. Because any number or letter raised to the power 0 is equal to 1. Plus, next, you see, 2 factorial from here is equal to 2. So what I have is 2. And a to the power of 1 and b to the power of 1 will still be ab. So I have 2ab. Plus, you can also see 0 factorial. Then 2 factorial will cancel 2 factorial. A raised to the power 0 will give me 1. And therefore, 1 multiplied by b raised to the power 2 will give me b squared. So it agrees with what we have as the value of a plus b raised to the power 2. Very good. Now, we want to try it when we are given a plus b raised to the power 3. Okay? How do we expand it? Explaining using this formula. You know, we have what we call Pascal triangle. But I don't want to go through Pascal triangle this time around. In this part 1 of the video, we will still take a look at the Pascal triangle in the next video. But in this case, we want to make use of exactly the formula for expanding binomial theory. So that even if you are given an expansion that has a power of 10, you can easily apply the formula instead of trying to generate the Pascal triangle. Alright, we continue. At this point, what I now have is n factorial all over, remember n minus 0, which is now going to be, okay, I go straight to the power, which is now 3 factorial all over 3 minus 0, which is 3 factorial, then 0 factorial. Then I have what? A to the power of 3, and then b to the power of 0. Next I have is 3 factorial all over 3 minus 1, which is, remember, k here is equal to 0, 1, 2, 3. So I have taken the first one for 0 plus the second one. The plus is because of the summation sign, alright? But remember, the whole of this here is taking care of the coefficient, which will be like here, the coefficient is 1, here the coefficient is 2, here the coefficient is 1. So we move on. Okay, 3 factorial, when k is equal to 1, I now have it as what? 3, look at the formula, 3 minus 1, which is 2 factorial, then 1 factorial, because it is n minus k factorial and then k factorial. That value of k, you put it in the second instance, alright? Then here we now have it as a to the power of 2 and b to the power of 1, because what I have is n minus k, which is 3 minus 1, which is 2, and here k is exactly 1. Beautiful. Next I have is 3 factorial all over 3 minus, I'm taking now for 2, which is 1 factorial, 2 factorial. Then I have a to the power of 1, then b to the power of 2. Next I have is 3 factorial, then all over 3 minus 3 is 0. So I have 0 factorial, then 3 factorial. Then I have here a to the power of 0, then b to the power of 3. That is something I want you to observe. Notice with me that on the power side, remember a, b takes care of the powers, okay? You will notice that on the power side, the addition of the two exponents in a and b variable must sum up to the highest degree in the question that I am expanding. In this case, the highest degree is 2. So therefore, 3 plus 0 is 3. Okay, here 2 plus 1 is 3. Here 1 plus 2 is 3. Here 0 plus 3 is still 3. So you cannot get anything more than the power of 3 or less than the power of 3. Okay, then we move on. Therefore, from here, 0 factorial is 1. 3 factorial will cancel 3 factorial, giving me 1. And here b raised to the power 0 is equal to 1 as well. Times this will give me 3 raised to the power 3. Plus, what does it mean? The coefficient side, the whole of this evaluation gave me 1, meaning that the coefficient of the first is 1. we come to this. See what I have. Remember that 3 factorial here is equal to 6 and 2 factorial is equal to 2. So when I divide 6 by 2, I will get 3, implying that the coefficient in the whole of this is equal to 3. Therefore, what I have now is a to the power of 2, then b to the power of 1. Plus, I have it again. Look at it. Exactly the same thing I have here is what I have here, which is going to give me 3. Then a to the power of 1 and b to the power of 2. Alright, we move on. In the last part, you see 0 factorial is 1. So 3 factorial at the denominator, 3 factorial at the numerator. So 2 of them will cancel, meaning that the coefficient here is 1. And a raised to the power 0 will give me 1. Also, b raised to the power 3 is what will survive eventually. Therefore, the expansion of a plus b all to the power of 3 is equal to what we have here. Alright. You know, mass is life. Now, I want to expand a to the power of a plus b to the power of 4. Okay? And after that, we can stop. But what does it mean? It means that in this formula, we can expand any two variables to any power. Even if it is given to you as a plus b all to the power of 20. Just apply this formula. There is still a Pascal triangle, but you can't generate it, you can't keep generating it when you have larger powers. Okay? Now let us try this one for the last time, or let me just summarize this. See, remember the summation sign. That is the reason why you see this plus. Remember this part of the question. That is what takes care of the coefficients. In this case 1, in this case 3, in this case 3, in this place is 1. Whereas the variables part takes care of the powers of a and b, telling us that here a is to the power of 3 and b is to the power of 0. Here a is to the power of 2 and b is to the power of 1. Here a is to the power of 1 and b is to the power of 2. There is something I want you to observe. Notice again, so that we summarize in this, but the task I will give you is a plus b to the power of 5. You expand this using this formula. Now, what I want you also to notice is that here, the first variable starts with the highest power and it decreases. Very beautiful and important. The first variable, in this case, the first variable is a, the second variable is b. Now, the first variable starts with the highest power of the question. In the question, the highest power in the question, in this case 3. So it starts with the 3 and it decreases. The first one time a is to the power 3, next a is to the power 2, next a is to the power 1, next a is to the power 0, which is equal to 1. Whereas the second variable starts with the power 0. Okay? Remember the formula. Remember the formula. B to the power of k. Okay? So, the second variable starts with the power of 0. In this case, b is to the power of 0. That is why it is equal to 1. And we cannot write 1a, alright? 1a raised to the power 3. Then, here b is to the power of 1. That is why you can see just b. Because b ordinarily means b raised to the power 1. Okay, here b is also increasing. Alright? Notice that b starts with 0 and it increases in that order. Whereas a starts with the highest power and decreases. Remember, a starts with n and it decreases as it tends to the highest power. Okay? It continues to decrease. So, n minus 1, a raised to the power n minus 1, a raised to the power n plus minus 2, a raised to the power. So, it continues like that. N minus 3. So it continues to decrease. Whereas b starts with what? 0. And it increases. B raised to the power 1, b raised to the power 2, b raised to the power 3. You understand what I mean? Until it gets to the highest power in the question. Thank you for watching this video. May God bless you. Please share to your learning colleagues and watch out for the next part. God bless you.